Lesson number 29, Algebra, volume 4, application number 57. Set Rx of polynomial in the indeterminate x, which real coefficient form a vector space over the field R, which respect to scalar addition and multiplication of polynomial. R X and low compound plus form abelian group structure commutative ANSC. Low plus is associative. On Rx, Px Ax Bx belong Rx. Px at Ax at Bx equal Px at Ax at Bx. Ax equal In xn. In minus 1 xn minus 1 at A1x at A0. Bx equal Bn xn at Bn minus 1 multiply x power n minus 1 at B1x at B0. Px equal Cn xn at Cn minus 1 xn minus 1 at C1x at C1. Check. So the law is associative on Rx. Law plus admit neutral element Rx on Rx. Ax belong Rx exists. In belong Rx such that X at Inx equal Inx at Ax at equal Ax. Inx equal Dn xn at Dn minus 1 multiply xn minus 1 at D1x at D0. In xn at In minus 1 xn minus 1 at A1x at multiply x at A0 at Dn xn at Dn minus 1 xn minus 1 at D1x at D0 equal In xn at In minus 1 xn minus 1 at A1x at A0. In at Dn xn at In minus 1 at Dn minus 1 multiply xn minus 1 at point D1 at A1x at D0 at E0 at A0 equal In xn at In minus 1 xn minus 1 at A1x at D0. Method identification coefficient, identification coefficient. In xn equal In minus 1 Dn minus 1 equal In minus 1 A1 D1 equal A1 A0 D0 at D0 equal A0. Result Dn is 0, Dn minus 1 0, D1 0, D1 0. In equal 0 is the neutral element sought. In belong Rx. Law plus element admit symmetrizable. Ax belong Rx and In equal 0 belong Rx. Exist Is belong Rx such that As equal Is Ax equal In. Is equal Ln xn at Ln minus 1 xn minus 1 at L1x at L0. In xn at In minus 1 xn minus 1 A1x at 0 at Ln xn at Ln at Ln minus 1 xn minus 1 at L1x at L0 equal 0 xn at 0 xn minus 1 at 0x at 0. In Ln multiply xn at In minus 1 at Ln minus 1 multiply xn minus 1 at A1 at L1 multiply x at A0 at L0 equal 0 xn at 0 xn minus 1 at 0x at 0. Result In at Ln equal 0, In minus 1 L minus 1 0, A1 at L1 0, A0 at L0 0. Result Ln equal minus In, Ln minus 1 equal minus n minus 1, L1 equal minus A1, L0 equal minus L0. L0 minus result Is equal minus In xl. In at In minus 1, In minus 1 multiply x power x minus 1 at point A1x at A0. A element symmetrizable. C law plus is commutative on Rx. Ax any Ax Bx belong Rx. Ax Bx equal Bx Ax. Check. It followed that R and law compound plus form abelian group structure. Produce vectorial R multiply Rx value Rx alpha Ax correspond alpha multiply Ax. alpha belong R, Ax belong Rx. Satisfied axiom S1, S2, S3, S4, axiom S1. Alpha beta X equal alpha X at beta X, alpha beta belong here, Ax belong Rx. Alpha beta In Xn at In minus 1 Xn minus 1 at A1X at A0 equal alpha In Xn at In minus 1 Xn minus 1 at A1X at 0 at B In Xn at In minus 1 Xn minus 1 at A1X at 0. Alpha beta In Xn at alpha beta In minus 1 Xn minus 1 at alpha beta A1X at alpha beta A0 equal alpha In at beta In Xn at alpha In minus 1 at beta In minus 1 Xn at alpha A1 at beta A1 multiply X check axiom S2 alpha multiply A at beta equal alpha A at alpha B beta beta A B belong Rx alpha constant belong set real number alpha In Xn alpha In minus 1 Xn minus 1 A1X at A0 at Bn Xn at Bn minus 1 Xn minus 1 at B1X at B0 equal alpha In Xn at In minus 1 Xn minus 1 at A1X at A0 at alpha Bn Xn at Bn minus 1 Xn minus 1 B1X at B0 check axiom 3 alpha beta A equal alpha beta A alpha beta belong here alpha A belong Rx alpha beta In Xn In minus 1 Xn minus 1 A1X at 0 equal alpha beta In Xn at In minus 1 Xn minus 1 A1X at 0 check axiom S4 1 Ax equal 1 Ax 1 belong R Ax belong Ax check so the is the vector space over the field R abelian group R X and the law compound which is external composition law which operation in R product Cartesian Rx value Rx alpha Ax correspond alpha multiply Ax alpha belong R Ax belong Rx Rx form a vector space over the field R.